Hello, guys. My name is Omar, and I'm gonna talk about a different kind of inter-process communication that is available in RTOS. So Vivek already talked about semaphore and its application in consumer producer situation and in critical condition and in critical section situations. So this event group is a different kind of inter-process communication, and let's start with some definition. So event group is a collection of bits to which an application can assign a meaning to different tasks of that application. So one may think of event group as a bit field where every bit is a flag that corresponds to a certain event, and the event bit can be set or cleared according to the behavior or according to the status of different tasks within the application. And the state of the bits is altered to signal the status of a process to other functions. For example, if we have two tasks, let's say we have task A and task B, and let's say we want task A must must terminate itself right after task B is completed. So you may use an event group in that situation with the bit indicating the status of task B, which task A the can determine the status of task B. So whenever task B um completes its task, task A get will get notified and act accordingly. And this is just a simple example. This is just a very trivial example, and event group can be used in a much more complex situations with many tasks within an application. So when do we use event groups? When do we use event groups? Um, so when we plan on waiting for an event to occur, as I just mentioned, that for the above example that or for the previous example that I just mentioned, that task A will terminate itself after task B finish its process. So in such situation, we use event group. So the event group does not notify itself of any events. The functions using the event group must signal when an event is over, and we use a pointer for such a task. So all the event bits in event group are stored in a single unsigned variable of type event bits underscore t. And event bit 0 is stored in a bit position 0, and event bit 1 is stored in bit position 1, and so on. Let's see. Let's go to next slide. So this is pretty much an example of an event group situation. In this example, we are using a 24 event bits. So you have a 24 different type of 24 different events in this application, where only three of the events are where only three of the events are in use. And in this example, we can see that only bit 2 is set. So the uh, application program interface functions for event group. So as I mentioned, that event group API functions are provided to allow a task to among other things, to set one or more event bits within an event group and clear one or more event bits within an event group. As I mentioned, this is one way for inter-process communication to let other tasks in the process know the behavior of other tasks that are running. An event group can also be used to synchronize tasks. A task synchronization point is a place in application code at which a task will wait in the blocked state. And so this is kind of similar to the critical section situation where the task must wait in the background, and i.e. it's not consuming any CPU time until all other tasks taking part in the synchronization also reach their synchronization point. So let's move on. So these are the different type of event group API function. Obviously, you have the event group create, you have the wait bits, the set bits, and I'm going to talk about some of these in the upcoming slides. So now we're creating an event group. We use the X event group create. So as I mentioned, we use the event group handle underscore tx event group create set. So void. So this is a function that returns the handle. The handle is the event group handle underscore t by which the newly created event group can be referenced. So so as I mentioned, so this is the signal that will reference to an event when the event is completed. And this is the handle signal or the return type, the the handle. And every event group requires a small amount of RAM, a small amount of memory in the CPU or in the microcontroller that is used to hold the event group's state when an event group is created. Then the required RAM is automatically allocated from the free toss heap, from the free RTOS heap. So this is just an example of clearing event bits. Obviously, we have to first create the event group, as I mentioned earlier, and this is this is the signal function, which will signal which will reference when the event is completed or when the event is set. And we use the UX bits to clear. We use this function to clear the bits to which we want to clear, and so on. And if called from an ISR, from an interrupt surface routine, we use the X event group clear bits from ISR. And this example and this very similar to clearing bits, this example showing how to set event bits. And yeah, it's a very similar behavior of the clearing bits. And that's it for me, guys. Thank you very much.